Action.
Now we're in the basement of this high-performance home in Lebanon. So we're in the master suite. So we've stepped outside of the bonus room into the attic. So now we're outside, and we're going to highlight the heating cooling systems. Hello, I'm Eric with E3 Innovate. We're east of Nashville in Lebanon, Tennessee. We're on a job site that's mid-construction, so it's prior to drywall. And early on in the project, we met with the clients. We established their goals for the project. They really wanted to focus in on making sure that the systems of their home just worked. They weren't super interested in all the environmental and green components. They just wanted to ensure that there was proper thought given to the design of the guts of the house, the heating, cooling systems, and the shell. And we provided that. We've also been asked to actually execute some of that work in the field. And so you'll see some of those details brought out in some of the video that we're doing inside the home. But overall, we just wanted to bring you to the site, highlight these cool features that lead to a high-performance home. And those core features are thinking through your thermal envelope, making sure it's properly sealed, that you properly insulated it, and that you install the proper sized heating and cooling systems along with your indoor air quality piece, which is your fresh air details, making sure you manage humidity and proper air filtration. So let's go and check out the inside. So we're inside the home, and we're looking at the wall assembly. This is what we call a hybrid system, where we strategically use spray foam for the odd sized wall cavities, the rim bands. So once we've established a sealed shell using the spray foam, then we fill the cavities themselves, these are 2x6 walls, with the full depth of the 5.5 inches with spray cellulose. We've had a sealed envelope established with the spray foam, and we feel like that provides us the best of both worlds. It's a more economical system, it's more environmentally friendly because you're using a cellulose product instead of foam, but you're still, again, strategically using the foam to address the weak points in the shell. Now we've entered the great room. Here we've spray foamed the lid, or the roof deck. We've spray foamed some of the weak points and small wall cavities, and then we've finished by installing the spray cellulose. We've applied details like intumescent fire paint behind the fireplace, and again, tied the details around the windows and rough openings so that we have a sealed and well-insulated shell. Here we're in the garage, of course. Wanted to note a couple details. The bottom side of stairs needs to be properly blocked, and if foam's on site, foam is the preferred option there to provide a good seal underneath the staircase. So we're in the master suite. What's important in this area is that when we were working on the mechanical design, the heating and cooling systems, we were trying to design a mechanical system that would serve both this floor, the master suite, and the bedrooms below us that are in the basement. And through several iterations, we came up with a solution where we have actually a more traditional dual fuel high performance Lennox system up in the attic here, and then we have these chases that serve the zone, the basement zone, the bedroom zone below. And so again, there'll be a zone for the master suite, a zone for the bedrooms below. And we had to really approach it that way because the loads on this space and the basement were so low that you couldn't use a separate system for both settings. And so that's one of the reasons why you really have to give proper thought to the mechanical design when you're working with high performance envelopes, because you're lowering the load significantly, and you've got to then figure out how to match that load with the proper mechanical equipment. So here again, this is an application where foam is the appropriate solution for drawing in the ductwork into what we call the conditioned envelope. We want the insulation to protect, in a sense, this volume of space, this attic, so that the ductwork and the unit above are in what we call a semi-conditioned space. So that's going to lower the heating cooling load, as you can imagine. Instead of being 130 degrees in the summer, it's going to be very similar in temperature to the conditioned space inside the home, and that reduces the heating cooling requirements. So now we're in the basement. These are thin walls, so we've chosen to maximize the insulation value by using a 1.5 inch polyboard, which we cut and then sealed around the perimeter with can foam. So again, we've included as much R value as we can in this limited space. Over here is one of the bedrooms. Spray foam on those exterior walls. Again, we've installed some sound attenuation in the ceiling between this bedroom and the master suite above. And then around the corner here is the passive radon stack here. Encourage the builder to install radon mitigation passive system underneath the concrete slab with a vertical pipe, limiting 90-degree turns, which he's done. Limit your joints to only 45 degrees or less. And again, this provides a passive radon stack up through the house. This is the exciting part for us, where you get to highlight the mechanicals or the guts of the house. So we spent a lot of time early on before construction in designing the mechanical needs of the home, the heating and cooling requirements, matching those again to what we felt like the thermal envelope should be, and then ensuring that we have proper fresh air and dehumidification. So here again is the dual fuel Lennox system. It has an efficiency rating of roughly 99% on the furnace side, and then it has a heat pump that's in the low 20 SEER ratings, which is very high. It's the most efficient system from Lennox. And you can tell here we have two zones, again, breaking up the basement load and the main floor above us. And we have a really good filtration system here right at the base of the return plenum of the unit, so that all the air in the home here is actually filtered and has a UV bulb in there. To the left, we have a really exciting ERV. This has the ability to control the amount of fresh air you bring in. We'll properly program that. And then we've added a sensor permanently installed in the basement bedroom area that will monitor radon. And if radon levels go above 4, it will actually increase the fresh air intake to help dilute that radon. So these are really cool, savvy ways of ensuring you have basic fresh air, indoor air quality needs, as well as kind of handling the unknowns of radon mitigation as well. So now we're in the bonus room above the garage. Bonus rooms typically have a lot of issues because, again, imagine this space is actually above a garage space that's unconditioned. So you basically got to figure out how to properly insulate all 4 sides of this room, and that's not typically done correctly. Foam, again, is a great option in this case because you're dealing with vaults, and that's, again, a great application for spray foam. I foamed them all the way up through the vault and up through the ridge and down the other side. And we've actually foamed also the floor of the bonus room, which is the ceiling of the garage below us. So now we've had a very well sealed and insulated shell, and then we can properly heat and cool that with a nice Mitsubishi mini split system here. This is a ducted unit with a small compressor outside. And again, a relatively small space. It's going to be very comfortable. And again, it starts with a properly sealed and insulated shell. So we've stepped outside the bonus room into the attic. I just wanted to highlight the significance of properly sheathing this wall. Oftentimes this detail gets missed. We want to make sure that you provide an air barrier on this wall and that you've properly sealed that air barrier and you've insulated that air barrier. So that's part of the code. It's often missed. Some people just put bats in that wall. They don't perform well, and then people are frustrated by the performance of the bonus room. So this wall needs to be well sealed. This is a foil-faced polyboard that provides a radiant barrier and continuous insulation, and then there's spray foam on the other side. As we transition to the open attic here, this is, again, a large open attic. A lot of people, unfortunately, are foaming this type of space, not understanding that, again, this does not provide very much performance improvement because you're capturing all this volume, and now you have to control that. You have to semi-condition it. So it's best, if you're not going to have ductwork and you're not going to need this space for storage, to leave this a vented space. They've installed the Tech Shield, which has a radiant barrier quality in the roof deck, which is a great idea. And then we're going to seal the floor of this attic really well after the drywall's in place. And we're going to insulate this to R60. So again, thinking through where you need to apply foam properly is really important. And thinking through what we call the thermal envelope in advance of construction is also extremely important so that you can properly size the heating and cooling systems accordingly. So now we're outside the house. We wanted to highlight the mechanical systems, the heating and cooling systems. These are both heat pumps. You have a Mitsubishi mini split here that serves the bonus room that we talked about. The bonus room, like we indicated, is properly sealed and insulated very well with spray foam. And so the load, the heating and cooling requirements are very low, so we've matched that appropriately with the Mitsubishi mini split that's variable speed, has a variable speed compressor and fan. And then over here is a Lennox XP25, so that basically has an efficiency rating in the low 20s up to 25, which is extremely high. And that's matched to the master suite and the bedrooms below in the basement. So 2 zones, so we've zoned that. And again, that's going to be able to modulate with its variable speed compressor to match the load as it varies during the year. So here we're outside again on the other side of the home, highlighting the heating and cooling system for the basement, the full basement, and the main floor of the house. So 2 large areas, both being served with a 3-ton exterior coil. So that's impressive. Again, back to the design, back to properly sealing and insulating the shell. We've reduced the heating and cooling requirements by doing those things correctly, and so now we're able to use a much smaller piece of equipment to heat and cool the home. So again, SEER ratings in the low 20s up to 25, extremely high, and matched to a dual fuel furnace that has natural gas efficiency of up to 99%. So these are two of the most efficient pieces of air-to-air equipment in North America.